Yeah, I can. Yeah.
So welcome to today's Tuesday talk on promoting policy coherence for sustainability. The vulnerability, consequences, and adaptive planning scenarios process by our fellow Thomas Webler. Thomas has a very interdisciplinary background in electrical engineering, biomedical engineering, and environmental science and policy. Before joining the ISS, he has been working amongst others at Keene State College in New Hampshire and Western Washington University in the United States. His specialty is public and stakeholder engagement and decision-making about controversial technologies. He focuses particularly on coordinating policymaking with special focus on siting of controversial energy facilities such as deep ecological repositories for nuclear waste, wind energy facilities, and solar farms. Thomas has served thereby on many different advisory bodies, such as the OECD's Forum for Stakeholder Confidence and several US National Research Council's committees, among others, on assembled chemical weapons and unconventional gas extraction. Before we start, please keep in mind that we are recording this session. And now, Thomas, please, all the floors are yours.
All right, thank you very much, Akam. And thank you all for coming. And for people who are on Zoom or watching this in the future, thanks for tuning in. So I'm interested in this challenge of sustainability, right? We have these 17 Sustainable Development Goals, which everybody knows about, or if you don't know about, you should certainly know about by now. And the question is, you know, you can use SDG tracker to find out how we're doing on each of these goals, but there's the possibility that making progress on one goal could impinge progress on another goal, right? So it's more complicated than just working on 17 different policy goals, because, for example, growing food might conflict with energy, especially renewable energy facilities, which need larger spaces to produce the same amount of energy as do concentrated fossil fuel power plants. And you surely can think about a lot of different conflicts between these goals that could happen. So this has brought up this notion of policy adherence or coherence. I'm just going to close down. I don't know if this is showing on the screen or not. It's not? Okay. The problem is you just can't see the title. Policy coherence, which is basically, this comes from a paper written in 2012, an attribute of the policy that systematically reduces conflicts and promotes synergy. So even better would be like if we make progress on SDG 2, we also make progress on SDG 5. So this, you know, there's a lot of feedback and connections here. We need to think about how to jointly achieve these policy objectives. Now I've goofed this up by moving this thing, haven't I? Move this. Sorry, I'm just trying to move things out of the way so I can see the screen. Slide, there we go. Okay, so this comes from an OECD report in 2018, and it shows basically some of these challenges associated with achieving this policy coherence to achieve these sustainable development goals. And I'll just bring your attention first to these two, which is where we need to start in terms of building a political commitment to working across these policy realms to come up with jointly beneficial policy solutions. And the second is to define a strategy. So we need some way of thinking about this conceptually, right? How are we going to reach these goals? And then there's been a lot of scholarship on this lately. Here's a paper from Environmental Policy and Governments from October that reviewed some of this literature. And if you're interested in following up on that, I put that up here for you. Political commitments on this in the EU have been pretty strong. That was originally showed up in 1992 in the Treaty of Maastricht, but also expanded in future treaties. And now we have the UN and different international organizations, along with the EC, working to figure out how to institutionalize this idea of policy coherence. And most lately, it showed up in the 2030 agenda. So lots of attention being given to this question. The other part I want to draw attention to is this challenge of policy integration, which is part of policy coherence, is how we're going to bring together different knowledge and expertise on achieving policy objectives in a coherent way. And you know, there's a lot of reasons why we want to do this. Just want to see my title here. Why we would want to achieve policy integration. We want to get better governance. We want to eliminate these zero-sum competitions between policy units where one office in the government basically is competing with another for funding or for reputation or even office space, right? So sometimes they're competing with each other. We want to break down policy silos for transdisciplinary understandings. Everybody here gets that. And of course, don't forget the whole reason we're doing this, trying to make progress on these SDGs, is to promote resilient and human natural systems that we also want to live in, right? That are nice places to live. But the question is how? How are we going to do this? So a bunch of things have been written about this, but the question is, how do we do it? So I'm here to talk about this one model called VCAPS, as Akam spelled it all out there: vulnerability, consequences, adaptive planning scenarios. This is a method of working together with policy or decision makers to synthesize both local and scientific knowledge, to promote systems thinking, promote learning within institutions, and to facilitate this policy coherent governance. So what is VCAPS? This is your typical policy cycle. You start at the top there with some sort of problem that you want to solve, define the goals, and then you document what we know about this problem. We analyze the different conditions of the problem, why this is a problem. We look at different solutions. We then analyze those solutions, prioritize them, choose them, take action, revise, and learn. So it's a learning policy cycle. And VCAPS pretty much just works on these two units on the right here. So it's part of a bigger thing that's going on. But this is how we've been using it in the past, right? So we developed this method. Some colleagues and their names are on the last slide, with funding from the NOAA, the National Oceanic and Atmospheric Administration, over several grants in several different states on the East Coast of the United States. And conceptually, it involves participatory modeling with causal structuring of hazard events. So we're approaching this from a risk perspective, but we also integrate in ideas of vulnerability and then build in decision, deliberation, and analysis, which is a form of participatory dialogue that was originally advocated by the US National Research Council back in 1996. And it's been a model that's taken up by Ortwin Wren and previous colleagues in Stuttgart and at his organization, Dialogic. Built a model called cooperative discourse. It's kind of the same thing. There's several of these kind of models out there, but they involve linking science with public values and stakeholder preferences in a dialogic way to solve a mutual problem. Okay, so what do we do with VCAPS here? We structure discussions using this conceptual framework of hazards and vulnerability. And specifically, when we were doing this with NOAA, we were doing it in the context of climate adaptation planning. So we're working with local climate stressors, identifying how those stressors play out in the human ecological system. What are the consequences of those stressors? And then we look at the vulnerabilities and different management actions to deal with those, to interrupt those problems, to solve these, to prevent the negative consequences from occurring. So we do this by using a dialogue diagramming tool. We call it dialogue mapping, and they're causal diagrams, basically. We do it in real time in a room like this with screens. And in so doing, we're bringing in different types of knowledge. So we might also have some experts be invited to the room to share what they know. But largely we're working with local people and their local knowledge. Here's a picture of one of the groups. This is in Orange Beach, Alabama. This was done with funding from Mississippi, Alabama Sea Grant. And you can see there's, I don't know, a dozen or 15 people in the room. There's some more people on this side. And this is a city in Alabama on the coast that was worried about hurricanes and increased hurricanes and storms. So what do? We start with some sort of climate stressor that they care about. So before the process begins, we would interview all these people, find out what they're interested in, what they're concerned about. There would usually be a community champion who's bringing the group together and linking it to some of the community's key issues. In Alabama, as I said, it was hurricanes. In South Carolina, we did this. It was drought and wildfires. And in Maine, it had to do with changes to fisheries production. So it could be any climate stressor the group's interested in. And then we would start to ask them what outcomes could be associated with this climate stressor. So what happens in your coupled human nature system? Why do you care that maybe there's heavier rainfall than normal? Because we expect from climate change to see heavy precipitation events, right? More downfall, more rain in shorter periods of time. But so why do you care? And also, people are going to say, well, we worried about flooding. But the thing about doing this process is you want them to construct exactly how you get to flooding. Like, what does flooding mean? Flooding of what? Where, when, why, how? There's a lot of questions there. So we try to slow the process down and ask them, well, what does heavy rainfall do? Well, it leads to surface runoff and groundwater infiltration. Okay, what happens from surface runoff? Well, it mobilizes pet waste or on the ground, okay? It leads to ponding in roadways. Well, why is ponding in roadways a problem? Well, because that leads to ponding on sidewalks. And why is that a problem? And we talk through this with them. And as we're engaging them in this way, we're also mapping this out using these little figures and arrows. And we keep developing these kind of things. And part of the facilitation challenge is keeping people from jumping too far ahead, because we want to try to develop these strings in a way that makes sense. I don't want people jumping back and forth from pet waste to stream overflows. But we're basically working through, this is a little abbreviated version so you can actually read it. If we look at this third line down, streams overflow, we see floodwaters encountering buildings, we see doorways and windows leaking, we see floodwater ingress into the home, we see carpeting getting saturated. So this is the kind of diagrams we're making. And if we just take this, continuing here, we get to something we call consequences, which are a special kind of outcome. They're outcomes that people that are threats to humans or what they value. This is what we're really complaining about. So for example, here, the fact that floodwaters encounter buildings, that's not a consequence. That's something that happens. It's a consequence if the water gets in and then ruins something that we're sentimentally attached to. For example, it ruined mom's, the carpet I inherited from my grandmother, right? So now I have to throw that away. I lost something that can't be replaced. Or it disrupted my daily life because I had to spend 3 days cleaning my house. I couldn't go to work, kids couldn't go to school. And maybe that leads to insurance premium rises, or you get mold buildup in your house, which leads to health effects, which are certainly consequences. So we do that, and then after we've kind of constructed that, we start to ask people, well, what can we do about these problems? How could we interfere? How could we break this causal chain so that grandma's carpet doesn't get destroyed, or we don't have mold growing all through our house? And so we start asking people, what management actions could you take, and where would they go in this chain? So upstream, we could construct more retention ponds that would hold floodwater so that doesn't get into the streams and it doesn't lead to overflowing. We could sandbag around our houses to protect them floodwater from getting near our homes, right? We could flood-proof our buildings by doing a better job with windows and door ceilings. And you can see from this that these management actions can occur in multiple points of this causal chain. And this is part of what we think builds a resilient society, is when you have management actions operating at different points in this causal chain, in case something doesn't work, or you didn't stack up the sandbags high enough. Or when they were sandbagging this nuclear power plant in Nebraska, right on the river, it was the biggest flood. I think it was like 500,000 year flood, and this nuclear power plant was basically made into an island, and it was just sandbagged all the way around. But then somebody drove a skid steer into the sandbags as they were moving stuff around, and it broke the whole wall and the water flooded in. So sandbagging might work, but something might go wrong. So you want to have that next flood-proof the buildings just in case. So as far as mitigation, that can also apply to consequences. So example, we might avoid sentimental losses, even if water gets into our house, if we were warned ahead of time and told to move things from the first floor or from the ground floor to a higher floor, right? Now, some of these boxes I have as light blue and some as dark blue, and that's because we also distinguish between management actions that can be taken by authorities versus those that can be taken by individual people. So if the authorities did a better job of warning me, I might have moved grandma's carpet. And if I was better prepared, like I did a good job of warning myself, I could have moved grandma's carpet. All right, so the last step in this process is the vulnerability part. And this is where we introduce sensitivity information about the different components in this causal diagram. So sensitivity has to do with the fact that not all things are equally vulnerable when they encounter a given hazard. And take, for example, sunburn. We go out to the beach, we go swimming here, we take off our shirts or clothes or whatever, and we're exposed to UV sunlight. Some people will get a sunburn very quickly. Some people will take longer to get a sunburn because that's a different sensitivity. Same thing with these things. Streams are not all equally sensitive to heavy rainfall. It has to do with, for example, what is the existing state of soil saturation before this storm hit? If the soils were already saturated, then streams are going to be more sensitive to additional rainfall. What about buildings? If buildings are located near streams, they're obviously more sensitive to being flooded by an overflowing stream. Doorways and windows leaking has to do with the quality of building construction. So these things all matter too. this is what they end up looking like, these diagrams. Lots of arrows, lots of things. And the point is not to really have the diagram. It is to go through the dialogic process of creating a diagram together. And when we would report this out, what we'll do is take little bits of this diagram and highlight and talk about the discussion that took place. Okay, so that's how VCAPS was developed. That's how it's been used for hazard management. What does all this have to do with policy coherence for sustainable development? Because hazard management isn't the same thing as sustainable development. But are there some similarities? And so this is kind of work ongoing, right? This is partly what I'm doing here, is trying to figure this out. How do we do this for regional sustainability development or regional sustainable development when we want to make progress on multiple SDGs? So what I would propose here is that we don't start with a hazard or a stressor, but we start with a policy objective. And for example, a common policy objective is to decarbonize the economy. And one of the things you might do, or you might have a municipality or a state or a regional government do, is say, we want to install 30 gigawatts of solar panels. Okay, so since policy integration has to do with multiple units being present, we would start by thinking about who are the decision makers and policy makers that we expect might have an interest in this new policy objective of installing 30 gigawatts of solar. So we know renewable energy facility siting intersects with competing land uses like farming, grazing, recreation, historic protection, landscape protection, or viewscape protection, conservation, and housing. So we would then recruit these people to come and sit around the table and participate in starting to flesh out a diagram. So start by asking, okay, were we to install 30 gigawatts of solar, what would be the steps that would be taken? How would we do that? Well, first thing we do is start to look for places to put this stuff, right? Identify best sites. And then one of the ways we might do that, we might break this down into different quality sites. So wastelands like old landfills, forest lands, pastures, vegetable farmlands that are being used to produce vegetables, and so on. And this is just me hypothesizing how this might run, okay? And what I would think might be a good way to go about this is having small thematic groups work independently to develop this diagram and then try to integrate what they've come up with together, because they're going to see this problem differently. The agriculture people are going to have a much easier time of thinking about how agriculture is affected, and the housing people would have a much easier time figuring out how housing is affected. But let's just say they did this. They might say, well, we're worried about losing vegetable productive farmland. So we could include disincentives to select certain types of sites, like highly productive farmland. And we could go through, we could work out the production of these, we could develop each of these different strings here, right? People are worried about lost production of crops because they're worried about food security, or they're worried about healthy food in a local environment. So they might think about different ways of accommodating that lost production. Anyway, this is just hypothetical. I'm saying this whole causal model of consequences is a good way to collectively think through what might happen if we do X. And then we'd want to synthesize the input from these different groups. So the housing people and the farming people and the historic development or the viewscape people, The other thing we want to build into these diagrams, if we can, are feedback loops. Sometimes things you do downstream come back to have future consequences the next time around. Characterizing the threats and the sensitivities is a key part of that whole process. And we'd want to make explicit the trade-offs between the different policy units. So it's clear what one group is winning if another group is losing something. And then we have to find some way to negotiate across those policy domains. Like, okay, you're going to lose a certain amount of farmland and you're going to lose a certain amount of housing spaces, but we're going to gain in decarbonization. How are we going to negotiate those wins and losses across these different policy units? There's got to be some thought given to that. So will this work? It's a rough sketch. It's my ideas, kind of. What do we need? We need to figure out how to link these causal chains, these sensitivities, these interventions with the literature on sustainable development. So far, VCAPS has been largely about risk and climate vulnerabilities. So we haven't talked about it, written any papers about it in the context of sustainable development. Can this process feasibly be the way that policy integration actually happens on the ground? That's the hope. And to practically do this, of course, we'd have to actually find some policy actions and participants, maybe do a case study, bringing them together, see what works. It's always fun. If you want to know more, we have a website, vcapsforplanning.org. There's a whole bunch of papers listed up there. This is a picture from Wellfleet, Massachusetts, where we worked with oystermen. They were worried about climate change changing the temperature of seawater, leading to more Vibrio and food poisonings. So there's a lot of different kind of case studies that have been done using this model there. And I think it's pretty promising, and I look forward to hearing what people have to say about this, if they think it would work or not. And